These are your 4-1 notes on slope-intercept form. We're going to learn how to write equations in slope-intercept form, graph equations that are in slope-intercept form and using slope and y-intercept, and then eventually model real life. So slope-intercept form is just another form of linear equations. Right now we know standard form, and then this is the next form we're going to talk about. So remember we talked about equations are just names of lines. They tell us information about a line. And so the form of this equation is y equals mx plus b. And if you remember from chapter 3, m is the letter we use to represent slope, and little b now is what we use to represent the y-intercept of a line. When you rearrange the numbers and the terms of an equation so that they are y equals the x value plus or minus a b value, that is called slope-intercept form. So we've actually used this quite a bit. When we wrote our arithmetic sequences, we would have maybe 2 times the n value plus 3. When we did our proportional and non-proportional, we would talk about kx or y equals kx plus or minus a number. It's all really talking about a slope and then the y-intercept where it crosses the y-axis. So in this particular line here, if you notice, it crosses at the little b. This is the ordered pair little 0 little b. So whatever number is sitting there in the equation, that is where it crosses the y-axis. And then slope, you could count rise over run, to graph the rest of the line. So let's practice just putting equations in that form. Okay, the first one gives us slope, so we have the m value. It gives us the y-intercept, which is our little b value. So the first equation is just y equals 2x minus 3. The 2 is your slope, and the negative 3 is your y-intercept. Remember, this is the form we're going for. The number out in front of x is your slope, and the number following that is the y-intercept. Part 2, they give us m, so here's our slope, 1/4, and then they're giving us the y-intercept as an ordered pair. Remember, y-intercept can be written as an ordered pair or just as a number. So to write this equation, y is equal to 1/4 x plus 1. And the last one, they gave us m and b. So sometimes they'll say slope and y-intercept. Sometimes they'll actually use abbreviations, ordered pairs. In this case, they just use the m and the little b. Y equals negative 1x plus 5. Pretty simple there. So now if we have graphs, we should be able to give the equation of these lines, knowing that with a graph we can count slope, and with the graph we can locate little b. So little b is where it crosses the y-axis. That is the ordered pair 0, 1, so little b is 1. And if I find another point on the graph, say right here, and I count, to find my slope, I'm going down 1 over 1, 2, and 3. So I went down 1 over 3 to the right. My slope is negative 1/3. Remember, it's the change in y over the change in x. So my equation, y equals negative 1/3 x plus 1. For number 5, my y-intercept is 0, negative 1. So my little b value is negative 1. I find another point on the line somewhere that crisscrosses, and I'm going up 1 over 1, 2, 3, 4. So my slope here is 1/4. It's rising. It's positive. That makes sense. 1/4 x minus 1. And number 6, I have my y-intercept is at 1, 2, 3, 4, 0, negative 4. So my little b is negative 4. But it's a horizontal line. And so it doesn't rise any, but it runs. And so what I have here is my slope is a 0 rise over 1 run to get from one point to the next 0 divided by anything is just 0. So my slope is 0. Y equals 0x minus 4 can be cleaned up and say y equals negative 4. Remember, one direction of a line has one variable. Horizontal lines have 0 slope, so when you plug them in, it's just going to disappear and you get y is equal to -4. If you look at every single ordered pair on this line, they are all where the y is equal to -4. So I could also make a table of values, and 1 gives me -4, 0, -4, 3, -4. You're writing the equation, y is always -4. To graph using slope, we're going to write the equation in slope-intercept form so you know what your slope and your b are. So we're going to put the equation, use inverse operations, move things around, add, subtract, multiply, and divide. So my equation looks like this. Get y by itself. Plot the y-intercept, which is your little b. Right, so that's the ordered pair 0b. And then after you plot the y-intercept, starting from that point, we're going to count slope to graph the next points. You can use slope to graph as long as you have a beginning point. So in this case, our y-intercept is going to be our starting point, and then we count slope to find the other points. So if you look at this first example here, slope is -2, and my y-intercept is 3. So y equals -2x plus 3. So this is my little b, this is my slope. So I'm going to start at 0, 3, and then from that point, I'm going to count my slope to get to the next points. So I'm going to count down 2 over 1, down 2 over 1, or I could count up to 1 to the left. So as long as I have 3 points or more, you can connect and extend those points. You need at least 3. So remember, I graphed my point starting at the origin. To get to 0, 3, I started from 0, 0. But then when I counted slope, I started from that y-intercept. Number 2 needs a little bit of adjustment. For number 2, we got to put it in that form. So to get it into slope-intercept form, I need to move over the 5x. And I get 4y is equal to -5x plus 8. I always want to put the slope and slope first and then y-intercept in the back. And then I'm going to divide everything by 4. Everybody gets divided by 4 to get rid of that 4. So we get y equals -5/4 x plus 2. 8 divided by 4 is 2. So I'm going to graph my y-intercept. My slope is -5/4. My little b value is 2, or the ordered pair is 0, 2. So I'm going to go up 2 points. That's going to be my starting point. Count down 5. 1, 2, 3, 4, 5 over 4 to the right. I'm going to run out of room, so I'm going to reverse that. I'm going to go up 5 and 4 to the left. And there's my 3 points. Connect and extend beyond those 3 points. My graph has a negative slope, or my equation has a negative slope. My graph matches that. Y equals 5, one variable, one direction. So if you don't know how to do this, it's also the equation 0x plus 5. I can start at 5 and just run, and just run, and just run. That means I had no slope. If you can't figure that out, these are crazy tricky ones. You can make a table of values, make all your y values 5, pick anything for your x, and it'll line up horizontally. For x equals -4, there is no slope, so I can't put that in slope-intercept form because there's no such slope for vertical lines. It's undefined. So for these, you can memorize it or do the same thing. Make all of your x values -4, come up with 3 random y values, -4, 1, -4, 2, -4, 3. The points line up vertically, and then you connect and extend. Those always are tricky, so make a table of values until you really understand them. For a lesson summary, I can find it. I can't get my lesson summary to go. There it is. Put the following equation in slope-intercept form. So I want you to rearrange that standard form into slope-intercept form, and then graph the equation y equals 2x plus 1. Just watch that plus 1. It kind of moved over. And I want you to use slope and y-intercept. Good luck.